Okay, so I realized the reason none of this is working is because we are not calling that function. So let's do that. All we have to do here is model dot end turn, and should work as I was planning. Let's see. So now, well, let's do a nice full restart. New game. Draw a card. I'll end turn, and then I'll draw a card. And that card is, we haven't made the UI for the bot yet, but in theory, it's coming there. And now coming here, and everything is good. Okay, so that's pretty good. We're off to something here. So we're going to call this bot turn, which we'll write that code in a bit. But let's improve our logic and get some UI for the bot as well. So checking if you can end turn is good to be able to make that button disabled. But we probably shouldn't even show this button if the current player is not not us. So let's wrap this. Let's actually just do an if statement here. If model.turn current player is equal to model.players 0. So basically, if these two things line up, we will show that button. So let's refresh and come back here. And so we do see the button. Now, if I click this, the button goes away because it's actually this person's turn. So we're good there. Secondly, let's copy let's do something similar, and I'll do it above here. We're going to make an align, and it's going to have an alignment of alignment.top center. And within here, we are going to just put in that card list. And so similar to what we're doing here, but instead we want the player to be model.players1. Okay, so now we can actually see what this person would have drawn. Great. Okay, so let's do a little bit of some sort of, I guess, AI kind of here. What I want to do just to make the bot a little more like it's thinking is we're actually going to, for the purpose of this, put some awaits in here to make it seem like they're thinking. So we'll start by just doing an await of a future.delayed, and we'll use a const duration of, let's just do like 500 milliseconds. So that'll essentially, like this function I called, we'll actually have to wait, in which case that's good. Let's also await the bot turn so that this stuff doesn't happen till, actually no, this can happen because we're gonna have something anyways. And then we're going to do an await of draw cards. And this time we're going to pass in turn dot current player, whoever the current player is. And in this case, it will be the bot when we're calling it. And then let's duplicate this. So there's kind of like draws the cards, or waits, draws the cards, waits. And then what we want to do is check if the bot's allowed to end its turn, which it should be at this point because we can always end the turn. We want to then call end turn. So now we should have a bit of a cycle here. So I'm going to make a new game. I'm going to click this and end my turn. Bot's going to draw something, and then now it's my turn again. Bot, I end my turn. Bot's going to draw something. I can draw. So we have the simple thing. So let's put a little bit of logic in the can end turn because our business logic should be something like if turn. We're going to return turn dot, we have something called a draw count. As long as it's greater than 0, we'll say we can end turn. So now if I'll end this turn, I'll do this. And then see, I can't end my turn now, but as soon as I draw this, I will be. So this is just checking to make sure, our rules of this game is you can draw one card and then you're done. Pretty boring game, but it will get more fun. Okay, so we have that. We have our little bit of AI happening. What else do we need? Well, let's see. So we can draw. We have no concept of playing, playing a card yet. So let's do something like that. And by playing, we're going to, in this game, just to kind of make it closer to what we're going to eventually be building, which is Crazy Eights. By playing a card, we'll actually kind of like place it in sort of a discard pile. So let's create our discard pile. So we have this deck pile that's right in the center. I want to wrap this entire gesture detector within a row, and we will do a main axis main axis size of main axis size dot min, just so it doesn't grow all the way, and we can have other children in here. So we're going to make a new component called the discard pile. Dart, and it will be a stateless widget. We'll call it discard pile, and we will make sure we import material. Inside the discard pile, we're going to keep track of what cards are in it. So there's going to be a list of card models. We'll just call it cards. And let's also pass in that size ratio. So we'll go required this dot cards and then this dot size, and we'll set it to 1 by default. Okay, so inside here, we are going to make the container have a width of, again, the card width times that ratio. And we will have a height of card height times the ratio of size. Then let's put some decoration on this, box decoration, and we're just going to give it a border around the whole thing. So we can use border.all and give it a color of, let's just use colors.black, maybe like 45 or something, and a width of 2. Then within this, we are going to have a child, and it is going to be a stack because we want to kind of have all these cards stacked on top of each other. So we're going to make it stack, and we're going to take its children. And rather than just like putting them in here, we're actually going to take all of our cards, and we're going to do a map on it. And each time it runs through this map, we'll refer to it as card, and we actually want to return that playing card, and the card will be that card. And let's also set visible to true, because if it's discarded, it should be visible. Then we have to remember at the very end to convert it to a list so that it conforms to stack children. Okay, so we have a discard pile, and basically we did this, we have this row already ready here, so let's just grab our discard pile. And we need to obviously pass in cards. So in here we have, we already kind of set up a thing for discard, so we should be able to just go model.discards, and that should start to show up. So now we kind of have this. I think a little bit of space might be nice, so let's just add a sized box, width maybe 8, and this could be a constant. And I'm just gonna get rid of this comma. I like my size boxes just take up 1 line. So then we have our discard pile here. It's empty right now. Everything is good. So how can we put cards in this discard pile? Well, we're going to make a function called play card. So let's put that, let's think of a good spot to put it. We have draw cards. I feel like right here is a perfectly good spot. So this will be a future, so it can be async, and we'll call it play card. And when we are playing a card, we are going to require that the player model, a player is passed in, like who's playing the card, as well as what card are they playing. Makes sense. And it will be async. Now, similarly, we have a can end turn. Let's also have a bool get can play card. And it's going to accept a card model that we'll refer to as card. And oh, wait, this can't be a get because we're passing something in. So it's just a normal function. So can play card, what can we do in here? In this case, we're just going to return true. We'll just be like, yeah, you can play any card. It's a simple Simple as that for now. Okay, within our play card function, so first of all, we want to check that thing we just made. So if not can play card, and we'll pass in that card, we just want to return right out of here, so nothing else happens. When we're playing a card, we will take whoever the player is, and we will remove that card from them, which is that function we recently made, that all it does is looks for that card in their hand and removes it. So we have that. Then, in the case of this game, when you play a card, you're really just putting in the discard pile. So we can take our discards and we can go .add and we can add in card. Great. So it's been removed, it's been played. Technically, we could do this in any order, but logically in a game, it makes sense to remove the card before it's played. So we will do that. Then what we're going to do is, and I'm just going to stub this in. Certain cards can have what we'll call side effects. Playing, for instance, in Crazy Eights, playing an 8 allows you to sort of change the trump at that time, that kind of thing. So I'm going to create a future void function called apply card side effects. And it's going to take a card model of card. And in this case, we're just going to make it async, and we're not going to do anything. But we are going to remember to put it right here. So right when it's played, which can happen right here, we'll actually await the play card side effects, because that might be something asynchronous. Like I might ask the user for like, hey, choose what the new trump is, or pick a player that you want to apply this action to, that kind of thing. Right now, it'll do nothing. It'll essentially be instant, and everything's good. We also want to take our turn. Now we're storing something in our turns called action count. This is obviously playing a card would be considered an action, so let's increment that. And then we want to then notify listeners. Okay, so we have a play card. Now we need to actually work with it. So let's go to, we already have our playing card, I think it's called playing card, and you'll see we've so here's a playing card. We need a way to essentially make our playing card clickable, right? So the only cards that are obviously playable, at least in this basic game, are ones that you have in your hand. So let's go to our card list, and we've already kind of started by, we have this on play card function, which isn't being used. Like if I search for this, you're only going to see it in these 2 spots. So essentially, we want to kind of pass this function through. So I'm just going to get that started by going on play card, and we can just go on play card. Now this is getting an error because our playing card does not even know what that is. So let's figure that out. So we're going to have a final function on play card. And it's going to be a function that returns, just like before, we're basically just kind of daisy chaining, these functions to flow through. And then we want to go this dot on play card. And what we can then do in here is we want to wrap this around, I think around the whole thing. Let's wrap it around here. We're going to just put a gesture detector. And we can do an on tap. And what we want to do, because this could be null, let's just first of all check. If on play card does not equal null, then we can just run on play card. And we put exclamation mark here because we know it is this, and it is giving me an error because it's expecting the card to be passed through. So let's just pass that through. All right. So this essentially will hit this, and then this essentially will hit whatever our card list is, and our card list happens to be part of the game board. So let's look at our player's card list, which is this one here, and we can have an on play card now. Okay, so this is a function that card model will come through. And let's just for now do print card dot value or something, just so we can see if this is even working. Okay, so now if I click this and we scroll down, we should see a queen, 6. So we are playing, this is getting passed through all 3 of those things, and it is working. So, but what we actually want to do is, play that card. So we already created this. In our model, we have a play card. And the player we want to pass through is this player here, player 0. So just the same guy here. And the card we want to pass through is obviously this card. Okay, so that will call this play card, which will make sure that it can play, which right now is just returning true. And then it will remove the card. It will add that card to the discard pile. It will apply any side effects, which does nothing. It will increment the actions, and it will notify listeners, meaning the UI will update. So let's refresh. New game, and I will draw a card, and I'm going to try to play this card. There it is. It's in the discard pile now. End turn. Now, we have no logic right now. In theory, I can draw many cards, and I can play many cards, and everything is good. But let's implement a little bit of logic here. So in our game provider, in our can play card, let's just look at if turn.action count is less than 1, we can play it. So this will require, only 1 card can be played per turn. New game. Grabbing this card, I'm going to just grab a bunch. And let's just see, I can play the 4, but I can't play anything else. But as soon as it goes around the board again, he's going to play, and then I can draw a card, and I can play again. So our logic is working fine. Similarly, let's limit the amount of draws. So can end turn. Where's our draw card? Draw card. So up here, let's put a bool get can draw card, and it's going to return turn dot draw count is less than 1. So you can only do 1. Now, we also want to check here now when we're drawing cards, if can draw card, or rather if not can draw card, will return out. So now I should only be able to draw 1 card. So I drew 1, let's try to draw another. It's not letting me, but I can end my turn, or I can play a card. I will do both, and I should be able to draw again. Yep, so everything's working. My bot's playing. Well, the bot's not fully playing yet. All the bot is doing is drawing every turn. So let's go to our bot logic again, and we can essentially do something here to make him play a card. So let's go. Let's just do play card, and we'll use turn dot current player, and then card. Now we could we could write some logic to randomly pick a card or whatever, but let's just take turn.currentPlayer.cards.first. Now, we also probably, in theory, it's possible, although with this logic, I don't think it is, that there's no cards in the hand. So let's just make sure we wrap this in a turn.currentPlayer.cards.length is greater than 0, or we can actually refactor that to is not empty. Then we will allow them to play a card. And the play card essentially does all these things, and will allow him to put it on the deck. Let's also, whenever this happens, kind of add a bit of an extra delay, just to make, he's really thinking about playing. So I drew a card, I end my turn. Okay, and he decided to play that card because he can, or she. There, 10 went down. So obviously the bot every time is just going to draw a card and play whatever card they have. Everything is working as expected. So yeah, this is kind of what I would say is sort of our framework that we have set up now for for playing a card game. The rules are dumb. This game is not fun. So what we're going to be doing next is actually, which I've alluded to a few times now, is converting this to an abstract class, probably adding some more helpers and stuff. But we're actually going to start overriding certain things, certain rules, such as can play a card might be a little more complicated, like, oh, you have to have, this particular suit in order to play this turn. We can add more logic there. We're also going to be adding stuff for winning the game, which in Crazy Eights would be, hey, you ran out of cards, game is over, you win, or the bot. We'll also be making our bot turn because the game will have some business logic of, in Crazy Eights, there's all these rules. So we're going to be implementing, a bit of a better AI. It's not going to be crazy, but enough that it can actually, in theory, beat you. And lastly, we'll obviously be adding in stuff for card side effects. So playing like a 2 requires the other player to pick up 2, that kind of stuff. So excited for that, and we'll see you at the next one.